In the next unit, we're going to begin looking at patterns of numbers, sequences, series, and specifically here in this first section, scatter plots. Now, what we've done so far in our math is we have been working with equations where there's a value plug in for x and you get y. And it works for every single x value put in, you get the y value. What we want to do now is if I give you a lot of different points, how do we find an equation that goes through all the points? For example, if I were to give you these points, you can say that's a straight line. You can figure out the slope, rise over run, and then get it into a y equals mx plus b format. But if I were to have a point over there and a point over there, how would you get a straight line that goes through that? And the answer is there is no straight line that's going to hit all those points. But what we want to find is the straight line that is the best fit, meaning it's going to go through most of the points, or at least an average of the points from a set distance away from those points. So we're going to be looking specifically at three types of data. One is linear, that follows the path of a line. One is quadratic, which follows the path of a parabola. And then the final one is trigonometric, or as your calculator is going to call it, a sine curve. And our goal here is we want to model data. Notice the key word is model. We are not going to get an equation that hits every single point in this chapter. Rather, we want to see where does the data tend to go and then come up with an equation that models that data. So the first thing we have is the scatter plot here. Scatter plot is the set of all data pointed on a coordinate plane. So we got all these points here plotted, and there are all these dots just sitting in space. Nothing really special about that. The way the dots or the way the points are aligned, though, is going to be important. And there's three types of correlations that we're going to be looking at. The first is a positive correlation. And a positive correlation has a lot of data points that head up in a general direction that would have a positive slope. So if I look at all those points, and if I were to draw a straight line through the middle, that line has a positive slope. That's the direction that if I were to see, okay, where are these points heading? It's heading up and to the right. So it looks like if I were to draw a line through it, I would have a positive slope. Something that's got a negative correlation would look like this. I've got a bunch of points, and it looks like they're coming downward. And I could have some points scattered out here as well. But the idea is that if I look at a majority of the points, it is starting in the upper left-hand corner and then going to the lower right, which is a negative correlation. The final piece is no correlation. And no correlation could just be dots all over the place where I can't determine if it's going to be a rising slope or a falling slope for positive or negative. Or we could have no correlation, something that looks like just this circle here where the data is plotted. I really can't see, is there a positive slope or a negative slope with that? So that one would have no correlation. So our goal in this first section is we want to look at how do we determine how good of a fit this line we're going to have. So the first part is how we use our calculators to enter data. So the first thing here is we're going to come up with a real-life model of purchase price in thousands of dollars for homes in the United States from 1990 to 1998. So you can see here's the ordered pairs. Here we've got the x-coordinate and the y-coordinate. The x is the year, and the y is going to be the amount of purchase price in thousands of dollars. So this is actually $131,200, $134,300. They just made the numbers a little smaller for calculator purposes. We can also make the years a little bit smaller. So what we're going to do, and it sort of is alluded to down here, we're going to set the time equaling to 1990, or my x value being 1990. So when I put this into the calculator, this is going to be 0, 131.2. This will be 1, 134.3. This will be 2, 141 0.0, and so forth, all the way down to 8, 167.9. Now the question is, how are we going to graph that? And what we need to be able to do is we want to be able to go to our calculator and just type in the values directly into my graph, or into my calculator, and then have the calculator plot it. So in order to do that, we're going to hit two buttons. We're going to hit Stat and then Edit. So my buttons are going to be right here is Stat and then Edit. So if we bring in our calculator, get rid of that clear list, we're going to hit the Stat button, and then the first option we see is Edit. And you're going to see three lists here, L1, L2, and L3. And we're going to enter all our X values into L1 and all our Y values into L2. Now the calculator does work that you can put the X's in L3 or Y's in L1 if you wanted. But for us to use the default settings on the calculator, we want the X's to be in L1 and the Y's to be in L2. So we're going to start by typing in these values into the X and then these home prices into the Y. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. So we've got 9 points of data, and we go 0 through 8. Then we'll go to L2, and I'm going to type in these values. 141.9, 145.4, 147.7, 153.2, 159.7, and then 167.9. And I can see there are my ordered pairs. Now, one of the things you're going to want to check as you're inputting these values is to make sure you actually have all the values in. Sometimes a student will go through and they'll miss one value, so you'll have more X's than Y values. And you'll get an argument error if you try and run the calculations we're about to do if you don't have the same number of values in list 1 as list 2. So just double check to make sure you've got the same number of values there. Once we have all our data entered, we'll hit Second Quit, and we'll go back to the main menu. And there's a little picture of what we should look like. Next thing we want to do is we want to go to Stat Plot and turn plots on. Typically, we've always turned off the stat plots because that'll mess up our graphs. And so now we want to turn it on because we want to plot out the values that we have for our points. Stat plot is found up here above y equals, so we'll go second, stat plot. And see how it says plots 1 off, list 1 and list 2? You can see for all these plots, the default are list 1, list 2, list 1, list 2. So that's why we want to put all our data in list 1 and list 2. And we're going to turn our plots on. So for number 1, we're going to hit enter. And you can see the different options here. All we want to do is hit this on. If I wanted to change my X list and my Y list, this is where I could change it to say list 3 as X and list 1 as being Y if I wanted to use those different pieces. But for everything we're going to do, it's just easiest to keep it L1 and L2. And we'll keep the first type of graph on, which are specific points. Once I've got my plots turned on, I'm going to go to y equals and let me clear out all my sine and cosine stuff from the previous section. And you're going to notice now this plot 1 box is turned on, which is what I want. And if I hit graph, nothing appears. And the reason that nothing appears is because I've got my window set too small. Remember for my window when I look back over here, I had 0 and 131 and then I had 8 and 167.9. So my extreme points in my window are 0, 131.2, and 8, 167.9. These are my extreme points. So I've got to set my window so that I can fit those X values in and my Y values in. So a good window to set up is I want to go a little bit larger than this. So I see 0 to 8 here. That's why right here, X min would be 0, X max would be 9. if I compare to this, it's going to be slightly larger than 0 to 8. I'm going 0 to 9, and then x scale, we could go 0.9 or 1 in this case. The next one we look at are the y values. And my minimum is 131, my max is 167.9. So let's choose something a little bit smaller than that and a little bit larger, which is why we chose here 130 and 170. And then here the x scale they have is 10. We could set it as 4 if we want to make it 1/10 of it. But really your scale isn't the most important point here. So we want to set our scales to be slightly larger than our extremes for both the x's and the y's. And we'll just look at the extreme points for that. So we'll hit window and we'll go to 0, 9, and 1, and 130, 170, and 10. And then if I hit graph, I can see those are the ordered pairs that I plugged in. And I can see by that I don't have a straight line. I've sort of got this curved line that goes all over the place. Now, my goal is I want to come up with a line that goes through a majority of these points. Or if I were to look at it from a distance perspective, the distance from each of those points is a minimum. I'm not going to find a line that goes through all those, but I want to find a line that if I were to measure the distance, I would have the shortest amount of distance that I've lost. So the way we do this is, since this looks like a line going to the top, we're going to choose a linear regression. If the shape were to have a parabola shape with the dots, then I would choose quadratic. If I had something that looked like the swoosh, that would be a cubic. Or if I had a curve that looked like a sine wave or a cosine wave, I would choose the sine regression. So we're going to go and do this calculation, and it's under Stat and then Calc. And if I head down, I see linear regression, quadratic regression, cubic regression, quartic regression, a second type of linear regression, logarithmic regression, exponential regression, a power regression, a logistic regression, and a sine regression. All those different pieces we could look at based off of the shape of our graph. But since my picture that I have right here is closest to a straight line, we're going to choose linear regression of ax plus b. The reason we choose this is the ax plus b is going to give us something in mx plus b format. We know b is the y-intercept. If I do this regression, the y-intercept is attached to the slope, and we really don't want a plus bx. We want ax plus b. So for all the things that you do in this class, we are going to choose linear regression. And if I hit enter, I can see linear regression of ax plus b. And I'll do the calculation for the linear regression of L1 and L2. Now, there's one last piece that we want to add here. And we want to put in y1. And the reason for that is when I do this linear regression, I'm going to be given a lot of different numbers. And with these different numbers, I don't want to write them all down. I want the calculator to automatically put it into y1 and then graph the line for me. Because right now if I graph, we saw those points, and you can still see the picture of it, there's no line going through it. But in the end, I ultimately want to have a line that goes through these points. And in order to do that, I need to put a value into y1 so that the slope and the y-intercept would be there. So what we're going to do is we are going to, at this point, once we have the value in Stat, we are going to choose to store it in y1. And the steps that we are going to choose are we're going to hit the vars button. Then we are going to choose the y variable, which are the y1s, y2s, y3. We're going to choose functional because we're in functional mode, which is a y equals mode. And then finally, we are going to choose y1. So once I've got this linear regression typed in, I'm going to hit vars, go over to y vars, choose function. And there's your y1, y2, y3s that are in your function mode. So when I see linear regression ax plus b y1, I hit enter, and I can see y, I can see a, I can see b, I can see the r squared, and I can see r. all the different pieces that I need for my linear regression. Here, this A is the slope, 4.22. B is the y-intercept of 130.04222. That is going to be the line that is the best fit. That is the average of going through all the points. Now, if I hit y equals, I'm going to see that that data was automatically put in for me. If I didn't do linear regression and then those steps for y1, I would have to manually come into my calculator here and type those values in. But since I chose y1, it automatically did it for me. When I hit graph, it is going to put the best fit line that goes through that. And you can see it doesn't go through every single point. It goes to that point pretty well. But the way it finds the best fit line is it looks at the distance from the point to the line, the distance from this point to the line, the distance from this point to the line, and it's finding the smallest distance if it looks at the average of all those distances. So my graph here, if I look at the equation, it's y equals 4.22x plus 130.042 is my best fit line. The question that I'm asking is, what is the median purchase price in the year 2010? Well, I know that if 0 is equal to 1990, then 20 is going to equal 2010. So I'll go to my table and let me choose my table setup to start at 0 and the change of table being 1. Remember, 0 is 1990, 91, 92, 93, 94. There's the year 2000. And if I head down all the way to 20, that is the year 2010. And we can see the average median price there is $214.44, which is $214,440 since each of those dollars were in hundreds of thousands. So the points that you want to get out of this is how you store information into the calculator by choosing the Y1. You want to know how to plot the points by putting the values into stat then edit. You want to know how to switch the window here so you can see all your points in the screen by choosing your extreme points and then making those your X-min, X-max, Y-min, and Y-max. And then finally you want to know how to find something else further down the line to predict something in the future based off of the values that I have in my graph.